Hello everyone, and now I'll start with the session. Uh, Dear authors and invited guests, welcome to the technical session 7F. My name is Siddhi Audi and I'll be your moderator for this session. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the ninth version of International Congress on Information and Communication Technology. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London on 90th and 20th Feb, and this event is being organized in the virtual mode yesterday and today via Zoom Meets. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we will be having six presentations in total, and each presenter will be given a time span of 12 minutes, and 3 minutes will be given for the Q&A session. After 10 minutes, I will raise a gentle reminder to the presenter to conclude the presentation. Also, there is another request to all the participants. I request you all to stay connected with me till the very end, till the closing remarks. And if you have any queries or technical issues, you can contact me in the chat box. Now, just before we get started, I would like to introduce, let me just share my screen. I would like to introduce the session chairs for today's session. So the first session chair for this session is Mr. Professor Andrea Ria. So Professor is currently working as an assistant professor with the Department of Information Engineering of University of Pisa. His research activity is focused on low voltage and low power mixed signals IoT, integrated sensor interfaces. In 2018, he won the Hawaiian Italy University Challenge. He is a vice chair of IEEE student branch of University of Pisa. I welcome you, sir, to this session.
Thank you.
Now,
Thank
next,
you.
I would like to introduce the next chair of today's session, Dr. Pankaj Chandre. Dr. Pankaj is currently working as an assistant professor in Department of Computer Science and Engineering, MIT SOC, MIT Art Design and Technology University, Loni Karbhor, Pune. He's currently handling the responsibility of TCSION ERP coordinator in his institute. I welcome Pankaj sir. Pankaj sir, are you with us right now?
Yeah, yes, ma'am.
Yes, I welcome you to the today's session.
Thank you, ma'am.
Now I'll proceed to the presentations. Now moving on to the presentations. Our first presenter for today's session is Seema Hegde, ma'am. Ma'am, are you present with us right now? I think Seema ma'am are not present with us right now. We'll proceed to the next presenter. If the presenters are not available, we'll go to the next presenter, and when they return, we'll pick their presentations later on. So the next presenter is Caesar, sir. Are you present with us?
Yes, hello. Can you hear me?
Yes, sir. I would if you could just give your presentation right now. We've changed the order a bit because the first presenter is not present right now.
Okay, I can present now.
Yes, thank you so much, sir. I'll stop sharing my screen, then you may start with your presentation. So the paper title for Caesar's presentation is Analysis and Characterization of a Moisture Sensor for South American Wood Species. So you may start with your presentation now.
Okay, please give me a second.
Yes.
Okay, could you see my screen now?
Yes.
Yes, we
Okay,
can see your
thank you.
screen.
Okay, the project name is Analysis and Characterization of Moisture Sensor for South American Wood Species. The main authors of this project, Mariela Ábalos, Jorge Salazar, Guillermo Kemper, and the Professor Carlos Raimundo, and me, Cesar Cruz. Okay, the beginning of the paper talks about studying a muster sensor made for types of wood that they are usually in Europe or North America, because we find many commercial devices in those countries, but we have a lot of species in South America, and especially in Amazonia. This sensor checks how wet the wood is without needing to pocket it. They suggest using a special math model to make a detector or a sensor work better for South America and or other unusual types of wood. In this part and in the fundamentals of moisture detection in wood, this part whether is in the wood. First is talk about what the moisture content means in wood and why it's important, especially when it's around 30%. Then it looks into how the way wood conducts electricity. This can tell us about its moisture or humidity with something called the electric constant, right? Um, Understanding these ideas help us figure out the water level in wood accurately, which is super important for things like building and working with wood in the timber industry. The description of the testing process for this project, we look at different articles that talked about measuring how well wood conducts electricity, call it electricity, the electric constant. We got some wood samples uh, for uh, for this measure and checked them out using a VNA, the vector network analyzer. This helps us understand how the wood behaves and can be a reference for future tests. We use this model of VNA, and these are the parameters. We use lens corrected antennas. We look at frequencies from 77 gigahertz to 87 gigahertz. We put the wood sample at the same distance from each antenna and got the same measurements called the S parameters. This tells us how much power bounces back or goes through the wood. With the help of the manufacturer's software, we could find out the electric constant and loss tangent. The picture shows us how was this setup. Implementation and validation. For this project, we make a basic circuit and we use an interdigital sensor, and we use a basic microcontroller of 12 bits of resolution in the ADC converter for the data acquisition. To validate the circuit and validate the performance, in this initial setup involves connecting a traditional plate of capacitors to achieve high capacitance values. So as you can see, we have these preliminary results. We use a basic components like capacitors, resistors, and the operational amplifiers. We connected this interdigital sensor that we made to the circuit to measure how much the voltage changes in based on the electric constant. We use different materials with a wide range of the electric constant values to cover all possibilities. Then we recorded the voltage from the microcontroller, and after that We analyze this information using MATLAB. As shown in the picture, uh, as we expected, the voltage went up as the electric constant value increased. Conclusions and future works. This paper explains how to study and describe the wood moisture detector or the moisture sensor that doesn't need to touch the wood. Is not invasive. It's measure how much water is in the wood using a special method called the capacitance. The detector can be changed to work with different types of wood by just adjusting it with a special math model. To make the detector work, we made some math models for different parts of it and wrote programs to use them. Even through our first detector didn't use a fancy math model, we tried to improve it by focusing on a component called interdigital sensor. We believe we can enhance it further by using a more powerful computer instead of MATLAB, and by adjusting factors like the size and spacing of parts of the sensor. So I think that's all. Thank you.
Caesar?
Yeah.
Yeah, so nice presentation.
Thank you.
Actually, you worked on sensor, am I right?
Excuse me, I can hear.
You worked on sensor. You used some sensor in your project.
Yeah, we use a interdigital sensor. This sensor was made in a PCB. So for read the signal of this sensor, we use a basic circuit with amplifiers and basic components.
Okay.
So we, yeah.
What is the approximate cost of that sensor?
So currently we are in Peru and we use these basic materials. Maybe it's $25 only for the prototype. We don't develop our case or structure. And in the future work, we plan to change the microcontroller and make a PCB design, because in this case we use a protoboard and we test this model and the circuit, and we try to validate this process.
Okay, so I have last question. So can I consider your model as a generalized one?
Uh,
Actually,
could you,
you are using wood from your South America, am I right?
yeah.
So for my country, or you can say for any country, so can I consider this one as a generalized one?
Yeah, that's the plan. Maybe, if I'm not sure if I understand the exact question, but we plan to use this sensor for other countries. The plan is try to make a strong model to add different types of wood.
Okay, no issue. Thank you. Nice presentation.
Thank you.
I have just a simple curiosity about your works, and thanks for your kind presentation. I was wondering which kind of amplifier did you use?
This is a generic proposed amplifier. It's
Operational
op amp.
amplifier?
Yeah,
Op-amp.
it's
Okay,
operational.
okay.
Yeah.
Okay, thank you.
Thank you so much, sir, for your presentation. As all the questions are done, now we'll proceed to the next presenter.
CD, I think that the first presenter is come back because he wrote
Yes,
on the chat. Okay.
yes, ma'am has entered. Seema ma'am is back, so she'll be giving her presentation. Seema ma'am,
Am I
uh
audible?
yes, ma'am, you're audible. Uh, so the next presenter for the session is Seema Hegde ma'am, and her paper title is A Review on Smart Traffic Management with Reinforcement Learning. Ma'am, you can proceed with your presentation. I'll stop sharing my screen now. Just a gentle reminder of the time constraint. Please try to conclude your presentation within 12 minutes. Thank you.
Hello everyone. Myself, Dr. Simone, and I'm with my co-authors, Ramsula, Abhishek, and Ranjay. Today we are presenting the paper on a review on smart traffic management 3.
Seema ma'am, actually we are unable to hear you properly.
Okay. Is that is okay now?
There is a distortion on your voice.
No, ma'am.
Yes, there is some disturbance in your voice.
As the disturbances in the audio system.
Yes, ma'am. Same issue.
Is this okay now?
No.
No, ma'am, it's still disturb.
Changed my audio system. Is it better now?
Yes, ma'am, we can hear you very clearly now. You can start with your presentation.
My paper title is a review on smart traffic management with reinforcement learning. Um, when we talk about the traffic management, especially in Asian countries like India and all, the traffic itself is a big burning problem. So the traffic congestion will be a lot of burning problem over here, a lot of traffic jam and all those things will be happening mainly because of a insufficient rain optimized usage of a traffic signals. The statistics says that most of the traffic jam that happens in our urban cities, especially in the intersections, is because of a inefficient usage of a traffic light. What I mean to say is that the traffic lights will be always constant, like not looking into what's the density of the traffic that has been aligned in an intersection. It will be just will not be having a proper traffic management. So in order to have this better traffic management, we can go for having an intelligent traffic management systems. Of course, some adaptive traffic management systems are in research, but it has been not been yet implemented. So here we are proposing a model, proposing an ideology wherein we can utilize the reinforcement learning based systems for a traffic management. So the reinforcement based traffic control management system will be having an optimized dynamics in a traffic signal. Because of that, we can reduce a congestion as well as go for a safety based system. So in order to have this, we here had done a survey and we have found out, okay, what will be the better way of implementation of a traffic management system in real time. Whenever we talk about a real-time integration system, lot of integrations has to be done. Computations that we are going to do has to be very quick because of a dynamic change that needs to take place in the traffic signal. And therefore, the reinforcement-based learning will be a better option for us. So when we talk about a reinforcement-based learning is one in which we will be having a multiple components, like it will be having an agent, it will be having certain actions taken, and then some policies and the rewards. So the reinforcement learning basically will be having agents which are nothing but a software entity which will be deployed over an environment in which it will be available, and it will be doing an interaction with the environment as well as the system based upon which it does its self learning, and it's going to propose certain recommendations. And these recommendations can be used for the action taking. So based on the recommendations, certain actions will be taken by the reinforcement systems. And these actions will be having the rewards. Like it may be having a positive reward or it may be having a negative rewards. So if the recommendations what is being provided based upon that, whatever actions is being taken, if that action impacts very in a very optimized way, then it gives a positive reward. It's similar to a virtual tag. That's all. Then, if it is going to have an very worse situations, then it's provide a negative reward. So, based upon this feedback system, the reinforcement learning model will be continuously learning on its own, and finally, it's going to generate certain policies or rules based upon which the adaptive learning. And there are various types of models that's been available for a reinforcement learning. One is called as a Q-learning model, the other one is called as a deep learning model. And whenever we talk about a Q-learning model is basically a data-driven model wherein we will be having the data that will be provided will be the action and the state. So what are the states that we are having in our model? The states here for a traffic management system, a state means that, okay, what is the traffic density that is being there in the system, and how much traffic movement is been happening, and how long the queue is. So like this, and what exactly is the time duration that was previously adapted for such models. So all these things are the different states that will be available. And for these states, what exactly the actions needs to be taken, that will be provided by the Q learning. And this Q learning model will be having an Q factor expression, that's a probabilistic equation that will be computed. And this Q factor expression what we are having, that is going to provide a proper decisions. And based upon this decisions, it is going to implement the dynamicity which will be provided as an action, and thereby it improves the traffic flow and decreases the congestion and enhances the decision making. And we have one more model called as deep Q learning model. And the deep Q learning model is the one which will be having a Q value function that will be approximated by making use of a CNN. So it will be having a multiple level CNN that has been implemented, and this is going to have the more compared to the Q learning. The Q learning model actually only we are going to use it as a data table, whereas in the deep Q learning model, it's a combination of Q learning model as well as the deep learning, wherein multiple level CNN model is being implemented to which action and states will be provided, and based upon that, it is going to generate uh, the results, the probability of actions. So that actions will be implemented, and thereby it will be used. So if I go with the Q learning model and the deep Q learning model, what I'll be using, we can see that in the Q learning, when we adapt these traffic states for the Q learning model as well as the deep Q learning model, just to know, okay, which is more feasible, you can see that with time, with the increase in the traffic density, the Q learning model, what we are having, it's going to take more time. That is, the convergence time of the Q learning model is more compared to that of a deep Q learning model with respect to time as well as the traffic density. That means the Q learning model is the one that can be implemented in a traffic scenario where I'll be having only few states of the traffic that can be given as input. Whereas if I have a very complex multiple states that has to be given as an input for my Q learning model, then its convergence time increases, and as we are using the state tables will be there, and this convergence time obviously leads to the decreased it will be taking more time for the adaptability. So whereas if I'm having a very simple traffic pattern management system, then we can go with the Q learning model, and that Q-learning model will be having a simple implementation when compared to that of a deep learning. So for a huge complex traffic patterns, we can prefer to go with the deep learning model, whereas when we have in simple situations, then we can go with the Q-learning. The same thing has been compared even using an online loading time. That is, whenever we talk about this real-time implementation, then the data will be loaded in the real time, and that real-time data has to be processed very quickly. So what is the time that's been taken for this online loading of a real-time data? If that comparison is done, again we can see that with increase in the number of data samples that's being provided, our Q-learning model will be taking more time when compared to the deep. So from these things, we have concluded that the Q-learning models will be when we go for the reinforcement-based traffic analysis, the Q-learning models can be used in the smaller areas, whereas the deep Q-learning models can be used in the very complex scenarios. So but when we looked into how exactly we can go with the implementation of this, for a simulation purpose, this is very good. But when it comes to a real-time integration, a lot of integrations has to be done even with the hardware components, like what all the sensors that will be used by say, traffic scenario, and what are all the different signals that will be generated over my traffic signal. So all these things has to be captured as a state, and has to be given to this Q-learning. To this RL model, and capturing of a data and integration of that real-time data with the Q-learning model is also one of the biggest challenge. So we are planning to take up that in our next phase and implement it for a betterment of the urban transportation system in Asia. Thank you.
Seema madam.
Yes, sir.
Nice presentation.
Thank you, sir.
Yeah, I have only two questions.
Okay.
So first one, why you selected only reinforcement learning?
Okay, sir. The thing is, when we go, actually, I have done the same, the traffic management system using cognitive agent based models also. And when we compared with that cognitive agent based model, in fact, my research area is in the cognitive agents, where I have developed our own behavioral model for a cognitive agents. And when we implemented this traffic management system for a cognitive agents, the convergence time what was taken is more compared to that of a reinforcement learning. What happens in the reinforcement learning is that it will be in a process of cycling, wherein the based on rewards it is going to undo something and do something. So learn and undo is a process that will be happening in the reinforcement based learning, which helps the better policy making.
Okay, good. And second question, is it feasible in India?
That's what, sir. We have a challenge in integration of this model with the actual real-time scenario. Actually, under the smart city project, we have taken up that activity. The thing is, integration of this model with the sensors, actual real-time data from getting it from the sensors and implementing it in a very adaptive manner is a big challenge that we are having, and we are in the process of resolving that. I hope we do.
Okay, no issue. Good. Best luck.
Thank you, sir.
Thank you. Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next one. Uh, Bala, sir, if you're present in the presentation, in the Zoom session, please let us know. We'll wait for a few seconds. I guess he's not with us right now. We'll proceed to the next presenter. So the next presenter uh, for the session is Meha Shukla ma'am. Meha Shukla ma'am, are you with us right now? Meha ma'am.
Yes, I'm here. Can you hear
Okay,
me?
I would want you to start with your presentation. So the topic of Meha ma'am's paper is security of connected places. So ma'am, I'll stop sharing my screen, then you can proceed with your presentation.
Okay.
Hello.
Can you see my slide now? Okay. So my presentation is about security risks of connected places. I am actually working as a PhD part-time student in University College London. I have a 30 years experience in public, private, and academic sector. Let's start with what's a connected place. Now, if you actually look at the definition here, the definition is very complicated on the NCSC website, which is National Cybersecurity Center. But let's just talk about something simple. You know, there are sensors on the road that collect the data that take into urban data sharing platforms on which the IoT platform has multiple applications interacting, and together it creates multiple integrated services. Now, all this is, of course, meant for urban service efficiencies.
Shukla madam,
Yes.
please change your side, means your first slide is visible.
You can't see the remaining slides? I have already changed
Yes,
it.
ma'am, we are not able to see the remaining. Ma'am, you've not opened it in the presentation mode. Please
Yeah.
click on the slideshow and then you can change the slide.
I am on the slideshow, which is really strange.
Just refresh once because this issue was there in the last sessions as well.
Yes, now it's visible.
Yes,
It
now
is
we
now?
can see your slides changing. Yes, ma'am.
Okay, great.
Please go ahead with your
So can you see
presentation.
the smart products and applications here?
Yes, ma'am, we can see.
Yeah, okay. So this is the example of the smart products applications, which people are well aware of. So, you know, the applications based on the smart products, say, for example, the GPS. When you talk about the smart infrastructure, you can think of multiple sensors on the smart lampposts, which collect data about the pedestrians or traffic, and maybe even the smart EV charging platform, which I'm using for my research anyway. When you think of how all these things come together, these products and different sensors and data collecting platforms, then you can think of how this smart home applications work. You would have seen some smart zebra crossings, which just come up when they see a pedestrian. So these kind of connected products and applications and infrastructure together create some connected places. Connected place, to be very frank, earlier used to be known as smart cities. Now that particular term is not being used anymore because of multiple reasons. It is not just relevant to cities, it's relevant to rural areas as well. And smart doesn't really tell you the level of smartness. So we are talking about the connected place instead of smart cities now. Now, this particular study that I conducted at UCL takes into account smart street ecosystem. I define smart street ecosystem as the carriageway, the footway, the people who are conducting various activities on the street, the transport on the street, the buildings, the airspace, and the subsurface. Now, the purpose for this particular study is to enable to ensure that the crime opportunities provided in a connected ecosystem can be anticipated and security is thought through early on. Now, the main thing about the rolling out of smart services is that the local authorities give contracts to private operators to roll out these services. So the main objective was to assess the challenges faced by these local authorities in protecting the smart connected places from cyber attacks. The method used was, of course, qualitative interviews with local authority and government stakeholders, and even the private operators of this smart EV charging service, which was used as a case study here. all the specifications in the procurement contracts were mapped with NCSC's cyber security principles for connected places to understand whether they are really being implemented. The key area in scope was the cascading impacts of a cyber attack onto a critical national infrastructure like a power grid. Everybody would remember the WannaCry cyber attack, which paralyzed the National Health Service in the UK in 2017. So critical national infrastructure has been the focus here. And because we are talking about local authorities, it's about the governance of the cyber risks and not about the actual technical problems here. The study design was in 3 phases: preparation, data gathering, and analysis. So the data from the stakeholders was collected by comparing the actual procurement contracts of EV charging that were being rolled out. A focus group was created with the experts from National Cybersecurity Center and the government officials who were in charge of secure connected places. That was basically the objective, was to tap into their expert insights. We did a thematic analysis and came up with the root causes and findings at the end. So the stakeholders included, as I said, the NCSC, the DSIT, the Department of Science, Innovation and Technology, and the Department of Transport as well. The CPNI is the physical wing of the MI5. The Transport for London, of course, runs all the transport on the streets, so they were also selected. And then the 6 authorities who decided to participate were also invited. And finally, there was an EV charge point operator who wanted to remain anonymous, so he's not named here. Now, this ethical considerations were a no-brainer because the participants of the research were from senior people from reputed organizations, and they followed the professional code of conduct. So there was basically an ethical exemption for the research. Once the data was gathered, the initial insight says that the government understands the urgent requirement. However, there was some lag in the policies and standards. A lot of things are still under development. In terms of local authorities, the biggest observation was that they were not really aware of what the rollout of the smart EV charging services could really do in terms of cyber crimes. So they were not aware that a Trojan horse inserted through EV charging station could actually blow up the vehicle batteries. And the lithium batteries being very specialized, needed some specialized firefighters because it could reignite anytime. They were not even aware of the recent 2022 cyber attacks on the EV charging machines, where all the machines right from Moscow to St. Petersburg during the Russia-Ukraine war were just taken out of service by hackers. So these kind of impacts were not known to them, and that's why they were probably not so clear about what kind of cyber risk mitigation they should be putting in place, and they had not thought through all those scenarios. That's because of all this, the responsibility and accountability was outsourced to the private operators who were literally deciding what kind of requirements they should be meeting themselves. Local authority stakeholders actually made this kind of statement saying the cyber risks were not thought through in terms of such cybercrime scenarios, and the utter ignorance on this subject is phenomenal. City authorities did not analyze the whole ecosystem, so it was more about individual contract compliance that they were assuring rather than the assurance of the whole connected place. The consequence of the local authorities not being liable was also quite big because it was not really taking into account all the required factors. TfL actually had created, that's Transport for London, they had created a good framework. However, they were really agreeing to the challenge that all the requirements were not really there in their framework. And there was probably absence of resilience tests as well. So all these observations were put into 5 themes: lack of accountability across services to be protected, insufficient cyber resilience specifications, lack of operational governance, lack of assurance, and inadequate skills. So we divided these into the 5 themes and then came up with specific findings. So there were 3 key findings. One was, of course, lack of managing appropriate and proportionate controls for mitigating the cyber risks within the procurement process. So they were, I mean, the government policies and the guidelines fell short of exactly what needed to be done. Systemic risks were not governed. By systemic risks, we mean the cascading effects of a particular cyber attack, which could spread across the whole ecosystem. So there wasn't really enough guidance around how they need to be governed, nor were there enough skills. So the national policy and guidance said that the local authorities were accountable, liable, and responsible, whereas the local authorities were not really aware that they needed to do all this, neither were they set up for success. Well, there was a clear single root cause. All the people involved in the city designs, the city authorities, the utility operators, the transport operators, and the smart service operators, none of these people were really aware that they were building a connected place. So they were very much focused on their siloed obligations. So we gave 5 recommendations. One was enhancements to the NCSC Connected Place guidelines because they were really very high level and did not really touch the systemic risks. I would like to think that my points were taken into the National Cybersecurity Strategy, which was then published later down the line. But I'm sure there were many more people who had input into it. I think that the anticipatory policies and governance and risk management that was being advocated by the government and the tools provided for the same definitely needed some kind of upgrade. The level of accountabilities needed to own and govern the systemic risks need to be looked at because there is definitely no owner of a smart city or a connected place. So how would that governance really work or needed to be understood? There are many resilience forums in different cities who look after the physical disasters and all the kinds of issues that occur when there is a catastrophe, but people like Highways England and other organizations are still picking up on cyber events of this sort. So they needed to upscale their efforts. And there is a potential transformation of operating models, which is required across organizations, not just the local authorities. So these recommendations were received very well. And this research is basically one of the first in understanding how the resilience and security by design is embedded into the procurement processes, wherein the smart services, are really rolled out using the disruptive technologies. This is going to be much more of use if this particular framework that we have recommended would be used when the AI is also coming up into the procurement processes so quickly. It contributed to academic research for crime science theories. For crime prevention through environmental design is a big crime science theory, and this particular research contributed to that. In terms of limitations, I would say that my findings cannot be generalized because they were found using a very small sample, just 6 authorities, and they were also done in a particular period of time. So it was just the snapshot in that specific time period. So more research is required here. However, this particular research had a very good impact. The National Cybersecurity Center picked up some of my suggestions to enhance their security of connected places. The local authorities also realized that they probably need to ask things like doing a resilience test or a dry run for the business continuity of their operations. So they put some additional requirements on the contractors. The DSIT funded an alpha testing project. They had already funded it, but they changed the scope of that particular testing project based on my initial findings. They focused more on the governance. And my findings were also embedded in Horizon 2020 project, which was conducted across 7 European cities for multimodal optimization of road space in Europe. I would definitely want to thank the 2 professors who supported my research, Professor Shane Johnson and Professor Peter Jones in the UCL. Any questions?
Yeah, madam.
Yeah.
Am I audible?
Yes, you're audible.
Yes, nice presentation as well as your topic is very nice and nice work.
Thank you.
I have only one question. Actually, you
Mhm.
mentioned 4 or 5 methods for data gathering.
Well, the method is only one, and that is through qualitative interviews. But
Okay.
I did some kind of I built up some criteria of what kind of data needs to be gathered. So for that, I picked the EV charging case study. I made sure I identified the right stakeholders. I made sure I selected the right NCSC connected place principles, and I built up a questionnaire on top of that to be able to collect the data.
Okay, ma'am. No issue. Thank you.
Thank you.
Thank you
Yes,
so
sir.
much, Meha ma'am, for your presentation. And now I'll proceed to the next one.
Thank you very much.
So the next presenter for today's session is Bala Musa sir. So you were there earlier, but I didn't get the response, so I started the next presentation. Sir, are you present right now? If you want to give the presentation, you can right now.
Okay. Hello, everybody.
Okay, I'll stop sharing my screen. Then you can start. The paper title for sir's presentation is Remote Monitoring and Mapping of Health Equipment for the Correct Management of Pandemics in Africa using the Embedded Systems, the case of COVID-19 pandemic. So you may continue with your presentation now. I'll stop sharing my screen.
Hello, everybody. It is good you can see my presentation.
Yes.
Good. Hello, my name is Bala Musa BI. I present my paper. Title is Remote Monitoring and Mapping of Health Equipment for the Correct Management of Pandemic in Africa using Embedded System, the case of COVID-19 pandemic. My contents is one, contents and problematic, second, literature review, three, objective, four, methodology, five, application, six, implementation, and conclusion and perspective in final. In the context, this word is made in code of infraction project, the ETHE, laboratory for engineer of innovation of University Hassan Sheikh Ziguinchor in Senegal. For development of country, many equipment has installed, among other health equipment, solar equipment, drill equipment, and school equipment, etc., etc. However, once their infrastructure and equipments are installed, unfortunately, they do not benefit from effective monitoring despite their current budget invested for their implementation. In this work, we are interested in health installation using embedded system for the surveillance. But there are many installation. But in this work, we interested in health installation only using embedded system for the surveillance. Many work has been proposed in medical field for remote monitoring. Another previous work I cited Pons and Alwork, who present a modeling method of wireless specially designed for people with chronic disease to promote their independence. Another work is Scardani Day and all proposed an intelligent solution for remote monitoring people with diabetes and obesity. In the work on gen and all sub-regional information system for management, the limit the previous work as the emphasis is only monitoring patient. The installation is not monitoring. In addition, the data acquisition is done on the same seat. But in our contribution, we integrate the hybrid with the technology of real-time system, embedded system, and GIS in order to better monitor distribution center installation. The black color is existent work, previous work. The red color is remitted, and the green color is our contribution. Embedded system. The objective in this work is to present it embedded system contribution in the file for health and remote monitoring. We design a structural of the remote monitoring platform. We presented database for storage. We presented analysis of data, the treatment data of order to make decision to intervene the maintenance team in the event of detected failure. And in response to this, we propose it algorithm for taking into account time and priority. This algorithm is presented in this diapositive. First, we are installation to monitor, and the equipment installation are embedded system for acquisition data. And if data as acquisition, we compare it. The time is real time, and after condition is verified, we send measurement. If measurement, if P equal 1 divided TE, we execute. If else, we wait, and wait messages are additional and notified message, and send another message for executives. The principle is based on the respect of the time constraint. The model we have proposed initially will generate nature of approach. This allow us to put in practice a space related to embedded system, the Internet of Things, and real-time system. But in this, we are installation repartition in our territory. The installation are embedded system for acquisition measurement, and T1, T2, T3, etc. is the time of output measurement. And this output measurement as treated, and we has send it this output treatment on remote monitoring center. We have proposed an algorithm which make it possible to title the acquisition values, and the treatment consists of checking if the values collected are within the limit of normal operation. In this diapositive, we are presented one georeferencing data. We have bias mapping and storage data. And the number 2 is software and functionality. The software and functionality are composite data modeling, mapping, and records. And the free number is computer hardware. The computer hardware as composite on application of application server, application data, and user station. To take into account the distribution of the installation, we are coupled the internal functionality of our platform users found in the GIS. And this is an example. To identify further equipments, we conceive the measurement table. This table is likened to the measurement acquisition system table, and output this list of measurement made. This table, we are the respirator, we are on column of a different question, and another column is inspiration air in oxygen, another column in the inspiration air in the oxygen. We are a different respirator. Each patient are another respirator, and after we have in right column inspirated air and expirated air. If on of the output is wrong, an alert is sent. And we repeat the action as many times as there be wrong measurement. All the failure equipment for locality of obtained by the following formula, and this total is df1 plus df2 plus df2, etc., etc. Data is georeferencing and organized by in a thematic. We are many later. The layer of remote monitoring elements. Another layer is phone network. Another layer is computer network, road network, solar network, etc., etc. This is a cartography of our locality who is concerned by on our application. The conclusion. Proposing in a generate model of a distribution installation system, composite embedded system and technology guide for remote monitoring of distribution sanitary equipment. Hello, 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 hello.
Yes, you are audible.
Yes, sir, you're audible.
You continue, please.
Okay. This work is opponent of many research perspective or general distribution installation model mapping to consider different application variety of installation. Additional of generate approach and cool. Hello, hello. My connection is very bad. Hello.
Yes, you are audible, sir. Hello, sir. I think we are not audible to you, but we were listening to you. I think there is an issue. Has he left the group chat?
Bala sir. Yes, he left, ma'am.
Okay. There might be some technical issue. Sorry for the inconvenience, everybody. But I think for now, as we have the time constraint, we'll just continue with the next presentation.
Yes,
If
ma'am.
Bala sir returns, uh, we'll just continue with his conclusions or Q&A session later on. But for now, it would be appropriate to start with the next session. So I'll go ahead. So the next presenter for today's session is Roa El Azobi, ma'am. Ma'am, I hope you're present with us.
Yes, I'm here. Hi, everyone.
Okay. The paper title for ma'am's presentation is Speech Emotion Recognition using Support Vector Machine. Ma'am, you may start with your presentation now. I'll stop sharing my screen.
Okay, thank you. Yeah, hi, everyone. So are you able to see my screen? Okay, so I will proceed assuming you are able to see my screen. So hi everyone. So my name is Roa, and I will be presenting the paper which is titled Speech Emotion Recognition using Support Vector Machine. So this is the outline. We'll start with the introduction, then the methodology, and then the discussion, then the conclusion. So starting with the introduction, speech emotion recognition, or SER, is a field of study which concerned with identifying and classifying emotions from speech signals. So basically, the main idea or objective is to develop algorithms and models capable of accurately identifying the emotions conveyed by speech signals. which entails like categorizing the speech signal into several emotions such as joy, sadness, fear, happiness, and many emotions. So speech emotion recognition has attracted much attention since like machine learning and AI were developed because they can generate more reliable and accurate findings than the traditional methodologies, and because they can learn also from very large data sets of speech signals and gradually increase their accuracy. So our contribution is basically review and analyze the existing literature on speech emotion recognition. We also developed and implemented several machine learning algorithms, and we evaluated the performance of the developed models in terms of the accuracy and other metrics, and we convert them to the state-of-art techniques. So the methodology, we first start with data collection, feature extraction, data preprocessing, model training, and the model evaluation. So starting with data collection, so basically in this paper we used a well-known data set which called RAVDIS, Ripson Audiovisual Database of Emotional Speech and Song data set. So the data set actually consists of speech and song recordings that have been labeled with emotional categories, 8 emotional categories. So it contains like 24 performers, 12 men and 12 women, where each of them contributed to around 1,500 recordings, where they were required to express a range of emotions through speech and song, like calmness, being happy, being sad. So they were asked to do simple phrases like, for example, I feel happy today, or I'm very angry right now. So this data set were used due to it has a variety of emotions. It have like around 8 emotions. So it considered a good data set for testing and training models and researching the connection between speech and emotions. So this is just a graph representing the 8 emotions which is in the data set. There is the sad, surprise, neutral, angry, fear, disgust, calm, and happy, where we have like around 129 to 122 files for each emotion. So after getting the data, we had to do feature extraction because like using the raw data or turning the raw data into more unique for representation of its characteristics is very important, which then can be used to be fed into machine learning algorithm to be used as an input. So in working with audio files, the most commonly important features in the audio files are the MFCC, chroma, mid frequency, contrast, and tonets. Due to the importance of all of those features, we extracted all of these features from the audio files using Python, Librosa library on Python, which then returned like an output of vector feature vector representing the features, which help in enhancing the results of the machine learning models. So for data pre-processing, like few steps were implemented, like the data augmentation. So it's very important. Using data augmentation in machine learning is used to expand the data set size and diversity, where it can help in generalization and exposing the models to more data variations, which will allow the model to learn to be more resilient to minor shifts or making more accurate predictions on a new and unseen data. And also it can help prevent overfitting by providing new samples that hasn't been seen before by the model. And as we saw, like since the dataset which we used contains like limited audio recordings, as we mentioned, like around 129 file for each emotion. So we try to use that augmentation like to generate more samples, which then can be used in the training. So for augmentation, we use several augmentation techniques for the audio files, such as pitch shifting, time stretching, and noise injection. For example, like the time stretching involves changing the duration of the audio signal without changing its pitch. Noise injection involves adding different noises to the audio signal, which can help like simulate variations in the background noise and the recording. So then for encoding, since we are dealing with categorical labels, so we had to convert them into numerical formats, which can be understood by the model. We also done feature scaling, which is used to convert the input characteristics into a scale appropriate for the machine models. Because it's important also to be used when the input features have different scales or ranges. So for model training, we tested actually multiple models to compare the results. We used support vector machine, decision tree, random forest, gradient boosting, and KNN. And also we implemented convolutional neural network and a multi-layer perception neural network model. And for the evaluation, we use the known confusion matrix for evaluating the models such as accuracy, precision, recall, and phone score. So this is the table which represent the results for the classical machine learning algorithms. The highest one was the support vector machine, which got an accuracy of 85%, and the next one was the gradient boosting, having an accuracy of 79. And we can see also that the recall precision F1 score values are also close to the accuracy, which means the model was able to classify the emotions correctly. This is the results of the multi-layer perception model, which got an accuracy of 70%. Like we can see that the accuracy is increasing over epochs, while the loss function or the loss error was decreasing over the epochs. This is for the CNN model, which got an accuracy of 83%. We had an early stopping function to stop the model when the accuracy is not improving. So the model was had stopped at epoch 37, with while it reached an accuracy of 83%. So this is a comparison between our results and the results which has been done in the literature. So a few works, most of the works which has reported here also use the same data set that we use. So the result was varying between like using deep learning models or support vector machine models, but basically the result that we got was higher from the results which was already reported in the literature, where our work had an accuracy of 85% comparing to the other works, which was less than the 85. So there has a few our study also have a few limitation. While like it achieved promising results, but there are room for improvements and future directions. For example, like our data set only contain an emotional speech by actors, which might not be representative of emotional speech in real life. And also like the data set have only 8 emotions, which might not be also representative to the full range of human emotions. And also like the data set was mainly in English, so maybe we had to check for other languages. So future study could incorporate like more diverse data sets and examine different emotional categories. And as I mentioned, like the data set only target the English languages, so maybe it will be also a future improvement, like to check other languages. But in general, like our model had a good result of 85% in accuracy. So for the conclusion, like as we mentioned, like speech emotion recognition is an expanding field with multiple applications. We use the RAPDIS data set where we employed and trained different machine learning model, and we combined them also, and we applied a deep learning model. We use like 5 different audio features to take advantage of each features to enhance the accuracy and the robustness of our model. And we also use data augmentation to increase the diversity and improve the generalization of our model. And like our best model was the support vector machine, which had an accuracy of 85, followed by the CNN model, which had an accuracy of 83%. And this is the conclusion of the presentation. Thank you.
Andrea, sir, please.
Sorry?
Am I audible?
Yes.
Yes, sir.
Okay. So nice presentation.
Thank you.
I think you have results of your project. Am I right?
I have what?
Results implementation.
Yes, and by Python, yes, which
Yeah.
is
Okay. So I have
yeah.
one question. Which activation function you used?
I think it was sigmoid for the deep learning.
Sigmoid for deep
Yes.
learning. Yeah.
Yes, for the deep learning, yes. For the support vector machine and other models, it's a classical machine learning algorithms, but basically also we implemented the grid search, like just to fine tune the models and to get the rest of best hyperparameters.
Okay. And how many samples you have for your data set?
So before augmentation, it was around 1,400 records, but after doing data augmentation, the total was around 7,500 records.
Okay, good. Thank you.
Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter.
Thank you so much.
Now this is the last presenter of 7F session. Wilbert Villalobos, sir. Are you present with us right now?
Yes, I am.
Sorry for the mispronunciation. Sir, the paper title of Wilbert sir's presentation is the multilingual eyes multimodal travelers app. So you may start with your presentation now. I'll stop sharing my screen.
Great. Can you guys see my
No, cannot see your screen right now. Cannot see right now. Yes, it's coming.
Great. Good morning and good afternoon, everyone. My name is Wilbur Villalobos, and I'm a junior at Keene University. And today I'm thrilled to present the Multilingual Eyes Multimodal Travelers app. It's a pioneering application transforming the travel experience for tourists and visually impaired individuals. Although it was originally designed for this, its use cases and functions are vast in what it could be applied to. This is a novel prototype application, and it was created by myself, Dr. Julia Kumar, and Dr. Jenny Geely. Great. So the Travelers app stands at the forefront of revolutionizing human AI interaction. By integrating object detection and language translation, we're not only enhancing the user's experience, but we're redefining it. It was meticulously crafted to enhance the travel experience for tourists and those with visual impairments by fusing object detection, language translation, and conversational AI, and is designed to bridge language barriers and improve navigability, making travel more accessible and enjoyable for everyone. So if you could just follow my cursor over here, I'm just going to do a small walkthrough of the high level overview flowchart. So at the start of the app, uh, there's a language selection option. Its default is English. And once you allow webcam access, it loads our Coco SD object detection model. It draws boxes around the models and it implements the labels. Depending on the language selection, it'll translate the labels and it'll incorporate this into the input for the chat message and send it over to ChatGPT 4. And then from there, it'll respond with the message. And by implementing the label, it makes it somewhat context aware. Great. So the Travelers app, it integrates cutting-edge AI technologies for real-time object detection and translation, language translation. For the webcam detection, it uses Coco SD's pre-trained model to identify objects in its class's dataset and label them with a confidence score. So if you take a look over here, it has a TV, laptop, mouse, and cup in its default language, English, with a confidence score. And the good thing about pre-trained models is you could always add on top of it, allowing for versatility for specific uses. So in order to translate the labels, we came up with a custom-made translation method, which maps out the English label to its equivalent in the supported languages that we included, which are English, Spanish, French, Russian, and Chinese. So the translation methods, it somewhat works as like a dual method. So when selecting the language, if you look over here, it says Russian right over here. So it was picked in Russian. It'll return the label to its corresponding translation. So over here, these are in Russian, and in turn, along with the labels, the selected languages also incorporates ChatGPT 4's multilingual capabilities by using a switch case in order to respond to the selected languages. So right over here, we picked Russian, the labels are in Russian, and the response is in Russian. Great. So just a bit of some code snippets right over here from its data set. It has about 85 to 89 different classes that it could identify using object detection. So right over here, toothbrush in English is toothbrush, and right over here are its corresponding translations based on the language. So over here in the function, once we translate the label, it'll return the translations label in the selected language, and if not, it'll just return the default label. So it being implemented right over here, the same picture that we saw before in English, right over here, it's in Spanish, in Russian, and in French. So from here, besides the object detection, also incorporating ChatGPT 4's API, we feed the labels into ChatGPT 4. So once an object is detected and labeled, this information is fed into the ChatGPT 4 model, making it generally contextual aware and giving a contextual response. So when the user selects the language, the switch case directs ChatGPT 4 to respond in the chosen language. So with this, coupled with the translation methods, this ensures that both the labels and the ChatGPT 4 responses are presented in the user's preferred language. Great. So diving a little bit into how it processes the messages. So I use the switch case in order for here get language instructions. So depending on the language that you select, it'll respond in the chosen language. And then right down here, we have language instruction. It's going to be equal to the language, get language instruction, which is how it's going to respond. So down over here for the system message content, once it detects the labels, it'll be fed the language instructions. And then from its current understanding, it'll give back the labels that it detects. And it feeds all of this into a prompt into ChatGPT, and it'll respond based off of the language instructions and the labels that it detects. So our goal, in order to make this more inclusive, we put emphasis on a user-friendly interface. So it's designed to be intuitive and allowing users of all ages and technological proficiencies to navigate and utilize the app with ease because of its simple layouts and its straightforward menus. It also has an option to use voice commands such as speech to text, oh, excuse me, and text to speech to cater to a wide range of users. And the importance of user-friendly interface is the most important thing is to reduce the learning curve for new users, which is particularly important for travel-related applications where users may need immediate assistance. And being user-friendly, the app becomes more accessible to a broader audience. Not only is it important to include people in need, but it's also important to include everyone. So here's a look at what the user interface looks like. So right over here on the browser, you can see the webcam with the object detection. And right over here is the chat section with the two options to either speak, as in speech to text, or to read the last message, text to speech. So here's the browser and here's a mobile version of it. So for practical applications, there's a variety of things that you could consider. If you were to consider a visually impaired individual navigating city streets with the aid of a guide dog drone, all powered by the Travelers app object detection and route guidance, or even a tourist in a foreign hospital, where the Travelers app translates medical terms in real time and breaking down language barriers in critical situations. But apart from traveling, it could also be utilized in military operations, where autonomous navigation and real time translation in confidential operations, or even cultural exploration and education, which enriches cultural experience by providing contextual information and historical insights at landmarks. So, since this is just a prototype, we do have in mind a lot of future improvements that we could include into it, incorporating next generation models um, with Apple Vision Pro's new spatial computing. Um, the Traveler's app, it could overlay relevant information directly into the live image, enhancing its understanding of its surroundings, and also improved accessibility features, potentially introducing a refined voice control feature and compatibility with screen readers. Great. Here are some references. So to conclude, the Travelers app is more than just an app. It's a step towards a more inclusive world, a world where traveling is not about reaching a destination, but about the experience and learning that comes with it. It's about making the journey accessible, enjoyable, and enlightening for everybody. Great, thank you. So I put two links here. One is to test out the app. Oh, sorry about that. Just real quick, I do have a live available. So right over here is in English. Sorry.
Thank you, sir, for your presentation.
Great. So right over here, you can see it detects both a cell phone and a person, and it tells me what I could do with it. Right over here is Spanish. So here's the translation in Spanish, and I'll ask the same question. Great. And its response is in Spanish. Great. So I put two links here, one to the GitHub repository, and right over here is a link to the browser. I'd like to acknowledge this research was funded by NSF Awards. And right over here is a picture that Keen kindly took of Dr. Kumar and I, which is my mentor. So great. Thank you guys for listening and taking time to listen to my presentation. And any Q&As are ready.
Thank you, Wilbert, for your kind presentation. I have just a curiosity. I was wondering if you tested your system also in outdoor application.
So somewhat we have, but I believe we haven't tested it enough just because it is kind of hard to find people that actually do have like um, visual issues in order to properly test it. But overall, walking around with it, it works as good as it does on the browser.
Okay.
Great.
Thank
Any
you.
other questions? Great. Thank you very much, guys, and have a great day.
Thank you, sir, for your presentation. I will proceed to the closing remarks. I guess this is the last presentation of today's session. So I will just a sec. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions. We hope to see you in the 10th version in 2025. All the presenters would be getting the digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also want to thank our session chairs, Andrea sir, and I would like to thank our session chairs, Andrea sir and Dr. Pankaj Chandre sir, for chairing today's session. And I would like to just give me a sec. I would like to display these certificates. As a token of appreciation to the chair on the behalf of ICICT 2024 Global Knowledge Research Foundation and partners. Thank you, you all, for your valuable presence. And before ending the meet, I have a small request actually. I want all the participants and chairs to turn on your cameras for a second so that I can take a quick snapshot of this session. If you don't mind, please just turn on your cameras. I'm waiting for the other participants. I request, please, to turn on your cameras. I just want to take one snapshot. We'll just wait for a few seconds and then. Thank you, sir. It's okay, Yulia ma'am, if it's not working. It's not compulsory. I just wanted to take a quick snapshot. Okay, now I'll be taking it. Just a second. Okay, I've taken the snapshot. Then you can end the meet now. Thank you so much, everybody, for your valuable presence and cooperation with me. Thank you. Bye-bye.
Thank you, ma'am. Yeah, bye.